Embedded concrete box culvert installation.
About 2.5 years ago was when the first incident occurred. The 6-foot pipe that was in there had started to deteriorate to the point where it had fines were falling out, and we was finding small holes in the road. This past spring, when the water came up high, it washed too much of it, and actually the right-hand side of the road actually collapsed. This is a natural habitat for native brook trout. That's important to us as well as the salmon, and this is ground zero for salmon habitat. We had a major road problem, but we also have a sensitive habitat right next to us. The Sandy River's right here, so our goal was to solve both problems as quickly and as affordable as we can.
Preliminary design. After site surveys have been completed, initial designs should consider a variety of structure types to best fit the site. The engineer hired to develop plans for the Bragg Corner crossing considered a bridge, an open bottom arch, and an embedded box culvert for the site, and concluded that the best fit for cost, site conditions, and construction logistics was a box culvert.
Concrete culverts, box culverts, have great benefits in that they last a really long time. We hope that this crossing will be in place for 100 years with really almost no maintenance whatsoever.
In this case, additional geotechnical surveys were conducted to better understand subsurface conditions, such as the potential to encounter bedrock, which would have made excavation for an embedded box difficult. Permitting during the design phase is an essential element of any stream crossing project, especially when working in an area such as Bragg Corner where endangered Atlantic salmon are present. Lead time is critical to address all issues related to protected habitats and for coordination with the U.S. Fish and Wildlife Service and U.S. Army Corps of Engineers, who are responsible for regulating all in-stream work.
Situations like this, they're incorrect. You got a 6-foot pipe, 20-foot brook. You cannot put that back in place. When it fails, you have to fix it correctly.
Construction drawings, review plans. Before construction starts, a design needs to be completed that shows enough detail so the culvert can be installed properly. For a large box culvert, key components are the location and elevations of the culvert inlet and outlet, final channel elevations through the culvert, and specific details for wing walls, road embankments, and water control structures used during construction. All elevations are established from a benchmark set during the initial design survey, and a description is provided on the construction drawings. Also included are specifications and construction notes with instructions for assembly of the culvert and specific requirements for water, erosion, and sediment control. An embedded box culvert requires specifications for materials and design of the stream bed to be constructed inside the box. It is vital that the right substrates are used to provide for stability of banks inside the box and so that at low flows, water does not simply seep into the stream bed. All construction drawings and plans must be provided to and reviewed with the contractor prior to construction. Fish removal.
We are in the town of Phillips, Maine, in the midst of the Sandy River watershed, which is known to be or to contain some of the best salmon habitat in all of Maine, which itself is the last bastion of Atlantic salmon habitat in the northeastern United States.
Before in-stream excavation and construction work, all fish were removed and relocated. Nets were erected across the stream above and below the work area to isolate the site. And then fisheries biologists worked their way through the site to move fish out of hiding places in the stream bottom, particularly in the pool downstream of the existing culvert. An electrofishing unit was used to temporarily disable the fish found in the work area, which were placed in buckets for a very short period, and then moved to suitable downstream habitat in the Sandy River. Water control. Water control typically consists of diverting stream flow around or through the work area of the construction site, keeping the stream flow clean as it passes through the crossing. Any dirty water encountered in the work area that picks up sediment is pumped from the site and run through some type of sediment basin or system to filter water before it can reach the stream. For this site, a temporary bypass channel was created to carry water through the construction site to avoid the challenge of pumping all of the stream flow around the site at a time of year when flows could be difficult to control. The bypass channel was lined with impermeable landfill liner and large rock, and was sized to pass a fairly large flow. Prior to any work taking place in the stream, a series of settling basins was constructed in the floodplain downstream, and a road ditch with hay bale check dams was also used at times to provide additional storage and filtering capacity for dirty water pumped from the work area. Cofferdams were installed at the upstream and downstream ends of the work area to route stream flow into and out of the bypass channel and to retain dirty water in the work area. At times, up to 5 pumps were running at the site to ensure clean water was passed through and dirty water evacuated from the site. 6-inch and 4-inch diesel pumps handled the clean water, helping to keep it out of the work area. And up to 3-inch pumps, 2 gas and 1 electric, were used for the dirty water. Site preparation prior to construction, delivery of materials. Prior to construction, materials and equipment should be brought to the site to minimize construction time. This is especially critical if higher stream flows are expected, as at the Bragg Corner site, and water control is more challenging. Initial excavation. At most sites, a large portion of the excavation can be done before the water control is initiated, as long as sediments can be kept out of the stream. For this site, in order to build the bypass channel, it was essential to excavate much of the fill at the site before water control cofferdams could be placed. While the bypass channel was being constructed, the stream flowed through the existing culvert. The cofferdams were partially installed during bypass channel construction, and when the bypass was ready, cofferdams were completed and the stream was rerouted through the bypass channel. The work area was isolated and further excavation could proceed. Preparing the bed for the box culvert. A large concrete box culvert embedded in a stream, in this case 21 feet wide by 45 feet long and 12 feet high, requires a deep excavation and a bed of firm, well-drained base material. The Bragg Corner culvert includes a 1.5 foot high footer block that supports the inlet of the box and helps prevent water infiltration under it. The bottom of this footer block required an excavation approximately 6 feet below the existing stream bed. The base of the culvert was set about 3 feet lower than the channel bottom to maintain a stable stream bed within the culvert, providing 1 foot for the thickness of the concrete bottom and leaving room for the culvert to be filled with approximately 2 feet of stream substrate. Installing the box culvert bottom. This box culvert is designed like a clamshell. The bottom was installed in sections to minimize the weight of each section and to leave the top open for building the stream bottom inside. The top was added afterward. Each section received caulking to be sure water doesn't leak through the seams, and all sections were cabled together to ensure a close fit. The 6 bottom sections weigh almost 40,000 pounds each, so a crane was needed to move them. Since a crane costs much more than a standard excavator, it was very important to carefully time the delivery of each piece in the right sequence to minimize the amount of time the crane was not being used, such as when the stream bed inside the box was being built. When all culvert bottom sections were placed, the lowest sections of the wing walls were installed to armor the inlet and outlet areas of the culvert and help direct flow to the culvert and minimize erosion.
4 wing walls, 2 at the inlet of the culvert and 2 at the outlet of the culvert. And at the inlet of the culvert, they help to focus the energy of the water flowing down into the culvert and to protect the stream banks and the road embankment.
Building the stream bed. After the bottom of the box was in place, a layer of sand and gravel was laid in the box. This layer acts as a cushion for placing large rocks forming the banks and provides a relatively impermeable layer so that when the bed is complete and stream flows are low, all of the water doesn't seep down into the substrate, leaving the stream bed dry. The large bank rocks are sized to be able to withstand the immense force of very large flows. Specifically, they are meant to be stable during a 100-year flood event. Substrate size was determined by stream survey data using hydrologic and hydraulic models. Additional gravel, cobble, and fine materials were used to fill gaps in the bank rocks, helping to keep water from flowing behind or around the bank rocks and to create relatively uniform banks. Several additional large rocks were partially buried in the channel to simulate the types of features found in other parts of the natural stream up and downstream of the culvert. Also, large rocks were placed to connect the natural stream banks upstream and downstream to the built banks within the culvert. These bank rocks help protect the wing walls and can provide passage for some terrestrial wildlife. Installing the box culvert top. After the stream bed has been built, the top sections of the culvert can be put in place. The seams between these sections are sealed from water infiltration with material similar to that used to keep ice and water out of roofing in a house. After the culvert top sections are in place, the remaining blocks of the wing walls are installed according to design specifications. Completed culvert and road backfill. In order to ensure a stable road and successful culvert installation, it is important to fill the site according to design specifications, especially in the immediate area of the culvert. The backfill over and immediately adjacent to the culvert must be laid down in small lifts of 12 inches or less and mechanically compacted with walk-behind plate compactors. The road beyond the area of the culvert is typically compacted with large equipment such as an excavator to minimize settling in the road surface. The surfaces of the road embankments are armored with angular rock to reduce erosion during high flow events. As the Bragg Corner crossing experiences large flows in the coming years, sediments will move through the culvert and some will be deposited inside to maintain a continuous natural stream bed. In a properly sized culvert like this, the natural channel continues uninterrupted through the culvert and can adjust according to storm intensities and provide for passage of aquatic wildlife even during dry summer months. The stream can act naturally and the road is invisible to the stream. Support for the production of this video comes from Poland Spring, the Sewell Foundation, and the USDA Natural Resources Conservation Service. StreamSmart is a collaboration of the following partners. Thank you to the following organizations and individuals who helped make this video possible.